Alright, the missus did me a favour and went and picked me up this ruuvi tag. So I've just yanked out the little plastic strip that unisolates the battery, and we're just going to quickly go through the setup process. I want to do it now, not that I'm ready to make the other video, but I want to do it now because it'll give me a chance tonight to muck around with it. Now, if I can't remember what it's under, there's a Bluetooth sensors option somewhere. Is it I/O? There it is, Bluetooth sensors enabled. Continuous scanning. No, we don't need a continuous scan, do we? HCI, what's that? Don't know. Do not know. There we are, ruuvi. Excellent. Alright, just like that. It'll be really interesting to see what data actually comes out of it. So if we go back here, we should see, I assume we should see another device here. Maybe it needs time. There we go, generic temperature sensor, there we are. Cool. You know what it doesn't have though? Does it have motion sensing? I don't think it does. No. Okay, so we're just going to use a generic. That's a bugger. Would have been really cool if it had because these things have got a motion sensing component to them. Let's give it a name. Because that's original. What we'll do is I'll go and have a look on the so basically all you need if you need to like programmatically interact with something on these things, as long as they broadcast messages on MQTT, you're laughing. So as long as the implementation of Bluetooth on this is forwarding information to the D bus, you'll get it on MQTT. So it's pretty straightforward. So the question came in from one of the guys on a comment on one of my videos. Can you integrate these things for automation? And that's what we're going to find out. Alright, good afternoon YouTube. Just responding to a couple of comments that were made in one of my other videos. I went and got myself one of these ruuvi tags. It appeared in MQTT like I was hoping. I was like, happy days, that's excellent. Guess what? This is really annoying, but when you set these things up, it should just appear in I/O, right? Down here at the bottom, it should have Bluetooth sensors. I've already seen this on another video, right? Like I've made another video. In fact, I've got the video of me setting this thing up, showing it working. Turns out, and I'm not sure how accurate this is, it's a 2022 post, that the servo controller itself runs in Bluetooth mode only for setup, because the limitation of the chip is that once it gets hot, it turns off. So this one, which is doing no work at all, has Bluetooth working. This one does not. What the hell's that all about? Anyway, I'll flash the forum post up. But that kind of makes the ruuvi tag a little bit pointless when using systems that have got like if you're in a hot area. A guy was commenting on one of my videos about how hot it was getting and his inverter was shutting down. Well, shit, man. Like if you Bluetooth pair stuff to the servo controller and it gets hot and it starts shutting down, you can't use it as a control anymore, can you? So I bought the ruuvi tag. Ruuvi tag failed. Not the ruuvi tag itself, but the servo controller, which is really disappointing. But for the sake of the video, I've got it working anyway, right? So it's not 24 degrees here now, I can tell you that. Let's have a look there. It's definitely not 24 degrees. And again, I still haven't cleaned up this spaghetti mess. So this is supplying 12 volts or 24 volts to this this relay, right? It's a 32 amp up to 440 volt relay. It's fairly oomphy. We usually use it for our spa. So when the power production's high, the battery's full, instead of clipping, we have the spa turn on and we use the power from the spa. Now the spa is tripping out our breaker at the moment because we think the heating element's going, so I'm going to attach something else to this to demonstrate this. In the interest of demonstrating what we intended to demonstrate with the ruuvi tag, I've attached this to temperature. So when the temperature goes over 35 degrees, this contact is going to snap shut for 500 milliseconds or half a second, and then it's going to snap open again, which will trigger this thing to move. I would have liked to have done this just as a latching relay on and relay off, but that's not how this thing works. So you don't have to do it that way. If you've got like ordinary loads that you're controlling with a relay, you can just latch shut or latch open, which is far simpler. The other thing is these things are available at Bunnings in Australia, and they're cheap, and so are they. I suppose that'll be the next step for me, is try and figure out how to integrate these. They're digital ons and offs. I haven't done it yet, but I'll look at that next. Anyway, we are currently at 26 degrees. Let's get a bit closer to that. My heat gun is, what have I got that's hot here? That'll do. My heat gun, which was my heat source, has become, where did it go? There it is. We're going to bang this in here where it's nice and warm. See if we can get the temperature to start going up, because that's nice and warm. Actually, I'll just hold it against the body, that'll be enough. We should start to see an increase in temperature. Now what I've noticed is there's a bit of a lag, and then suddenly it'll start shooting up. So what I can do is use the video editor to speed this up a little bit. So I'm going to let's do that. I'll show you what the code looks like in a minute. Well, not code, it's just in Node-RED. So 33, 34. Now this heat gun is attached to the relay, which we should hear click anytime in the next 10 seconds. It's just sitting at 34 degrees. Come on, 35. Now wait. So that triggered at 35 degrees. There'll be a bit of a delay. There'll be a bit of a delay because the body of the temperature probe's got to start. There it goes, 34, and it turned off. Happy days. How cool is that? So anyway, that's what we intended to do with the ruuvi tag, which didn't happen, disappointingly. But works on the normal temperature probe just fine. The only reason that we went with the ruuvi tag is one, that someone suggested it, but two, these things are notoriously expensive for what they are. Like you pay a blue tax anyway when you buy Victron's gear, but I don't know if the cost of this temperature probe is justifiable. So that's disappointing. Now one of the things I was, somebody else commented, and I've responded, one of the really interesting things about this is these temperature probes, if you, on the temperature inputs, you can get the voltage directly from the input. Whether or not it works with the tank, I'm not sure, but for the temperature probe inputs, actually MQTT shows you the voltage. So if you had another type of sensor that you wanted to use that isn't directly supported, as long as it's in the operating voltage range of the servo controller, you could use that as well, provided that you're going to put your own logic behind it. Probably isn't recommended by Victron, but what the hell, like if you buy their modular gear with all these extra outputs on it, I suppose there's an element of customization anyway, isn't there? Anyway, let's go jump on the computer and I'll show you how that works. This is the same one that I used the other day, so you can see the relay override is right there. This is going to relay 1, which was the second relay that we enabled for the fans. I haven't used that for today's example. As you saw, it was the heat gun attached to relay 0. So this is going to look a little bit funny because there's 2, and you're like, why is there 2? Well, because the relay is not a latching relay, it latches by virtue of the fact that it connects the AC terminals from the in to the out and stays on, but the input requires that is like a button press or a debounce if you want to speak Arduino talk. So what we have to do is we actually have to send it on, and then a short time later we have to send it off. So that's why this function's got multiple outputs. The first output is a debugging output. It's there just to pass through the information that we're getting. So while I was trying to figure out how to implement, basically the payload that came out of here got sent out. So let me just go back and explain this a little bit better. Normally you have message in with a payload and message out with a payload. You're not restricted to just message.payload. You can also have message. whatever other elements you want to add, because JSON's pretty flexible. This one's got 3, which means that we're not passing back a single element, we're passing back multiple elements. So if you create an array of message, you can send message 0, message 1, message 2, and you can send a group of them out. Now that's important for us because this state is expecting to receive value back. So if I jump over here and we look at the state here, state equals value : 0, so we want the relay to be off. This is on the end, so that's just notification. So if we go down here to R, or W, sorry, W is where we wrote the state. So the last state that was written to it was value 0, which turns the relay off, or open contact. So what's going on here is that we're setting message 1 turns the relay on and message 2 turns the relay off in both scenarios. So when the temperature is above 35, if the temperature state is not equal to 0, as in, hey, it's already turned on, then we adjust it. So if the temperature state is not equal to 0, as in it's currently on, we need to turn it off, and that's when we send those messages. Otherwise, they're not set. So only message 0 gets set, which is the debug message, which sends out the current temp, and a payload of -1. That's for like troubleshooting circumstances. The servo controller will not respond to -1, or it might, but it doesn't appear to do anything. If the current temp is less than 35, we're going to switch it off. So we're defaulting to the off state because you know, you want things to fail safe. However, if it is not less than 1, then we act upon it. So this temp state is something I'm saving in the global context. If you've used Node-RED, that should be fairly sort of familiar to you. I'm saving the state, so in between messages that we receive, I've got like a reference point. So we only change it once you go over 35. If it's already turned on, we don't send the on message again. This prevents the relay from flopping up and down perpetually. So at the top here, we get the temperature state, and we make our decision based on this. If it's above 35, but it's already turned on, the temp state is already 1, we don't need to turn it on again. So that's the point of this in both scenarios. If we're below 35, we don't need to continually switch it off. Because of the way that our relay behaves, that would actually just cause it to flop up and down, and that would probably be bad for whatever equipment you've got on the other side of it. So so I suppose, like line by line, we'll go store the current, or get the current state. This is a troubleshooting step. That was just me extracting the temperature from the payload. You don't need these ones. This is creating object. What's an object? We're going to populate the first that's only for troubleshooting. We don't actually use it. Then, if the temp is over, no, sorry, it's not, is it? If the temp is under 35, check if we need to turn off the switch. We do need to turn off the switch. So this line here is, this is just adjusting it. So I suppose the best way to explain this one is that if our current state is not equal to the stored state, we need to act. And since we're switching it off, we don't want to switch it off again. So we have to change the global state to say it's off. And that way the next time, while we're under 35, it won't trigger it again. I hope that makes sense. probably just made it more confusing than it needs to be. This is the servo close relay, and this is the, oh man, my typing skills are a bit, how you doing, aren't they? So that is the button press, effectively, is these two right here. And what's permitting that to happen? This one is just the reverse. So that's the switch off mechanism. That's the switch on mechanism. We could easily flip that. We could turn it around the other way if we wanted to. Put these contents down the bottom, these contents up the top, flip that around, and we could reverse the logic. So what is making the, like, what's the secret sauce here is this really, because both the messages, the on relay message goes out at the same time as the off relay message, and this intercepts the off and delays it. And that's what causes it to do the button press. If you're wondering what this shenanigans is up here, this is what sends the keep alive message. So I push this after I've made changes, and it causes this delay 10 seconds to wait for 10 seconds, and then it sends a message. But at the same time, it shoots down here to do this delay, waits another 5 seconds, and then that restarts the process. So you'll get a 10-second delay after I press timestamp in. It'll send the keep alive message, then it'll wait 5 seconds, and then another 10 seconds, so you'll get a 15-second break. Every 15 seconds thereafter, a keep alive message will go out. That'll keep MQTT running. Otherwise, what will end up happening is MQTT will go to sleep, and if it goes to sleep and something else doesn't trigger it, you'll miss the temperature message being published. So I probably have done a really, really horrible job of explaining that. But if you want to know more, or you got some ideas about how to, you know, something else you want to automate, let me know what it is. This could just as easily be automated on power. So we got a fair bit going on. We take the power inputs from all of our various AC coupled inverters. We push it all out to an influx database with various tags. So we've got a fair, oh, well, that doesn't look like it's working currently, judging by this connecting symbol. But yeah, there's lots you can do with it. You can get some pretty granular information about how your power system's working. We control everything, including our carport door. Like that's something. Like we use these Advantech Weiss 4060 devices. I got introduced to them at work when I was working around a mine site, and like these can extend the functionality of your servo controller, like giving you GPIOs, because they can be used with MQTT. So if you were to have this thing communicate to the same broker that your servo controller is running, and run node red on your servo controller, which you can on the large image, you could extend the functionality of your servo controller by adding these Weiss 4060s, and they're Wi-Fi. So hang on, let's go and have a look. These things. So 4 in, 4 out. You can get, like, you could add button presses if you wanted to. You could use the digital ins to simulate a button press, and then you could cause the servo controller to do something based on that, or the outputs are the same. They're just a dry contact, sort of like a relay. So you know, you could do it on a voltage low or a voltage high switch. There's plenty of options. But if you want to see more of that, or you've got any ideas that you'd like us to test out, just leave a message in the comments, and we'll do the best we can to sort of accommodate. Anyway, thanks for watching. I hope that's helpful. If you, for the guy who asked the question about the ruuvi tag, exactly the same applies. If you were to use a different temperature, you simply change the topic. Now I can tell you the ruuvi tag did show up. This is the article that was talking about the Bluetooth, and the limitation on the chip, only operating at low temperatures. In order to see the built-in Bluetooth connection, the unit must be cold. So that I hope that's not true. Like, I hope this guy looks like a pretty trustworthy fellow, but I don't know, like this rubs me up the wrong way. It's a waste of $50, I can tell you that. Anyway, here's what it is. Thanks for watching, guys. I'll see you in the next one.